A single shooter positioned miles away can bring an entire mission to a halt. Without being seen, without being heard. Just one shot, calculated with surgical precision. That is the power of modern precision rifles. And what makes these systems truly fascinating is not only what they do on the battlefield, but what they reveal about engineering, strategy, and the constant evolution of warfare. Each of these rifles carries decades of research, testing under extreme conditions, and continuous refinement. And understanding what makes them exceptional is understanding how military technology shapes the world around us. Before getting into the list, it is worth answering a question that seems simple but really is not. What makes a rifle truly dangerous? The intuitive answer would be caliber or range. But anyone who studies military weaponry knows the real answer is more complex. A dangerous rifle is one that combines accuracy, reliability, adaptability, and consistent performance under extreme conditions. Power without control is not an advantage, it is waste. Interestingly, this principle appears in many fields where mistakes carry a high cost. Medicine, aerospace engineering, and space exploration. In all of these areas, mastery of technology through human skill is what separates excellence from catastrophe. And in the world of precision rifles, this truth becomes absolutely clear. Starting in 5th place, the CheyTac M200 Intervention was designed with a very specific objective: engagements at distances that render almost any conventional system practically useless. Chambered in cartridges such as the 408 CheyTac, ammunition developed to maintain stability and energy at ranges beyond most traditional sniper systems, the M200 operates at distances where the curvature of the Earth begins to become a relevant factor in trajectory calculations. This is not an exaggeration. Shooters trained on this platform must account for Coriolis deflection in their calculations. The same effect that determines the direction of hurricanes is the same effect that can alter a projectile's path during an extreme long-range shot. But what defines the M200 Intervention is not just its ammunition, it is the concept behind it. A complete extreme precision system. When this rifle is deployed, it is accompanied by ballistic calculation tools that account for wind speed, altitude, temperature, humidity, and even the Earth's rotation during maximum range engagements. The shooter is not simply aiming. They are solving a complex physics problem in real time, combining applied physics with intensive training and sharp environmental awareness. Preparation and calculation are just as important as execution. A perfect shot begins long before the finger touches the trigger. It begins with terrain analysis, the reading of weather conditions, and the careful calibration of every variable that can influence the projectile's trajectory over hundreds or even thousands of meters. The M200's chassis was designed to maximize stability and reduce vibration during firing. Its bolt-action system ensures consistency with every cycle, which is essential when even a few centimeters of deviation can mean the difference between a hit and a miss at distances measured in kilometers. It is heavy and large, but these characteristics are not flaws. They are deliberate engineering choices that prioritize stability over mobility. Every design decision involves a trade-off, and the M200 made its choice deliberately and effectively. For the missions it was designed to perform, there is no substitute. In 4th place, the Gepard GM6 Lynx represents a completely different philosophy. If the Intervention is about maximum range, the GM6 is about intelligent design. It uses a bullpup configuration, which places the action mechanism behind the trigger, resulting in a weapon that is significantly shorter in overall length without sacrificing the ballistic performance of a 50 BMG caliber system. This type of engineering solution is rare because it requires completely rethinking the architecture of the system rather than relying on established conventions. It is the kind of innovation that only happens when designers have the courage to question why things have always been done a certain way. In urban operations, inside armored vehicles, or in difficult terrain, a smaller weapon can make the difference between successfully positioning the shooter with an advantage or not. The GM6 Lynx solves a classic anti-materiel weapons problem: how to maintain heavy firepower in a portable platform. This challenge is analogous to what computer engineers faced decades ago when trying to place increasing processing power into ever smaller devices. The solution always involves reconfiguring the layout, not merely reducing components. And when executed properly, the result is a qualitative leap that changes what is possible in the field. The recoil absorption system deserves special attention. Large caliber rifles generate tremendous recoil, and managing that recoil is critical for rapid follow-up shots and for preserving the shooter's health during prolonged operations. The GM6 uses a recoil-operated semi-automatic mechanism that distributes force in a more controlled manner, making the shooter more effective in situations that require multiple shots. The engineering behind this system involved years of testing and refinement, because balancing energy absorption with the cycling speed of the mechanism is a problem with no simple solution. The lesson here is straightforward. The most effective solution is not always the most obvious one. Reframing the problem already solves half of the equation. In third place, the McMillan TAC-50 is chambered in the powerful 50 BMG, a cartridge originally developed for use in heavy machine guns during World War I. The fact that it remains relevant more than 100 years later says a great deal about its effectiveness as a ballistic solution. What placed the TAC-50 at the center of discussions about extreme precision was not only its technical performance, but also its proven track record in the field. Special forces from different countries have relied on this platform in critical missions and in military weaponry. A reputation built in real-world operations is worth more than any technical specification on paper. Every successful mission adds a layer of credibility that no catalog can replicate. The TAC-50 is also known for its exceptional durability. Deserts with temperatures exceeding 40 degrees Celsius, Arctic environments with temperatures dropping below -20, high-altitude mountains with significant atmospheric pressure variations. This rifle has been tested and validated under conditions that destroy less robust systems, yet it continues to operate with the same consistency. McMillan has dedicated decades to refining its materials and manufacturing processes to ensure that every unit produced maintains the same dimensional tolerance standards, regardless of operating conditions. Environmental resistance is not a secondary detail. It is a fundamental part of the design. A weapon that performs perfectly in the laboratory but fails in the field is worthless. The TAC-50 has never forgotten that truth. Second place belongs to the SV-98, developed in Russia as a bolt-action system chambered in 7.62 54mm. Designed for medium and long-range missions where control and consistency matter more than raw power. The cartridge it uses has a history dating back to the 19th century, yet it has been continuously refined to meet modern precision requirements, a testament to the fact that good solutions endure when properly developed. It does not try to impress with the largest caliber or the longest range. It impresses through its build quality and ergonomics designed for the real shooter. The adjustable stock and grip design allow adaptation to different body types and shooting positions, which is more important than it may seem during long surveillance or reconnaissance missions. A marksman who spends hours in a firing position needs a platform that works with the body, not against it. Fatigue accumulated throughout a mission can compromise accuracy just as severely as any mechanical failure. There is a subtle lesson here. The most powerful option is not always the most suitable. In many tactical situations, a smaller caliber rifle with superior accuracy and a lower acoustic signature is far more valuable than a large caliber platform that reveals its position and attracts unwanted attention. Knowing when not to use the maximum available capability is, paradoxically, a demonstration of mastery. This operational wisdom is what separates experienced marksmen from beginners, regardless of the equipment they carry. And taking first place, the Desert Tech SRS A2 represents something different from everything presented so far. It is not the most powerful in terms of absolute caliber. It does not hold the longest recorded range in the field, but it is, quite possibly, the rifle best adapted to the realities of modern warfare and the operational demands of the 21st century. Desert Tech is a relatively young company compared to century-old manufacturers, yet it has created a system that redefines what is expected from a contemporary sniper platform. This is the kind of disruption that happens when a new company enters a market without the burden of convention and asks, how should this work if it were designed today, from the ground up? The SRS A2 is built in a bullpup configuration with a game-changing advantage: caliber modularity. The operator can quickly change the weapon's caliber, adapting the platform to different missions without needing a separate rifle. In modern conflicts where the operational environment can change dramatically within hours, carrying a single system capable of adapting is an enormous logistical and tactical advantage. Less weight, less equipment, greater flexibility. Its rigid internal chassis ensures firing stability even at extended ranges, while the ergonomic design reduces fatigue during long missions. Every component has been engineered to work in harmony with the others, creating a user experience that professional shooters describe as intuitive even the first time they handle the system. What places the SRS A2 at the top is not any single feature. It is the sum of everything: compactness, modularity, accuracy, comfort, and consistent performance. The future belongs to systems that adapt, not to those that dominate only a single dimension. In technology, business, or any competitive field, the ability to rapidly reconfigure for new challenges is more valuable than being the best at only one aspect. The SRS A2 is almost a metaphor for that principle. It does not try to be the biggest or the most powerful. It strives to be the most complete, and it achieves that goal with remarkable consistency. Returning to the question from the beginning, which one is the most dangerous? The honest answer is that it depends on the context. For extreme range and maximum ballistic performance, the CheyTac M200 is difficult to surpass. For mobility combined with heavy firepower, the GM6 Lynx solves problems that other systems simply ignore. For proven durability in harsh conditions, the TAC-50 has earned a reputation built through decades of real-world service. For consistency and tactical practicality, the SV98 delivers exactly what it promises without exaggeration. And for adaptability and modern operational effectiveness, the Desert Tech SRS A2 represents what comes next. What all of these systems have in common is that none of them operate alone. A precision rifle without a highly trained shooter, without environmental calculations, and without mission intelligence is nothing more than metal and machinery. What truly makes these weapons dangerous is the combination of technology and human preparation. The evolution of these systems reflects something greater: the constant pursuit of doing more with less, adapting to hostile environments, and combining power with intelligence. Every system on this list reached its current level because engineers, military personnel, and marksmen worked together to refine concepts over years, sometimes decades. There is no technological leap without collaboration between those who design equipment and those who use it in the real world. The most sophisticated tool in the world still depends on the mind that operates it, the training that comes before it, and the judgment that determines when and how it should be used. Precision is not an accident. It is discipline applied through method, repeated until it becomes instinct. And while technology continues to advance, the core principle remains the same as the one that guided the first elite marksman: obsessive preparation, a deep understanding of the environment, and flawless execution at the exact right moment. These rifles are the most refined expression of that principle, and studying them offers a deeper understanding of how excellence is built, both on and off the battlefield.